This video will look at the backward elimination process for carrying out stepwise multiple regression to find the best model to explain a particular dependent variable. The dependent variable that we will be looking at again is U5 mort, under 5 mortality. The independent variables include total fertility, female literacy, the log of GNP, CPR, contraceptive prevalence rate, DPT, health services, and safe water. The first step in the backward elimination process will be to generate the multiple regression results for all variables considered at the same time. To do that, we'll go to Tools, Data Analysis, Regression, and in the multiple regression window, we'll select under 5 mortality, this is Control-Shift down arrow, as the dependent variable. In the independent variable range, we will put all of the independent variables. Again, Control-Shift down arrow. We have labels in the first row, and the output range will be M1. When I hit OK, we get the multiple regression results, only some of which can be seen here. But we've accounted for 80% of the variance. More importantly, we have all of the variables and their coefficients, and here we have their p-values. We can see that actually only one in this multiple regression has a statistically significant p-value. That is the availability of sanitation. This is when all variables are considered together. But in the backward elimination stepwise process, we're going to take the variable that has the highest or largest p-value, and we're going to eliminate that variable from the analysis. The largest p-value is for safe water. So, in order to do that, I'm going to go back to our original data. I'm going to copy it. I'm going over to cell W1 and paste the data. And now, because safe water was the one with the largest p-value, I'm going to delete it. So now I have only 1, 2, 3, 4, 5, 6, 7 independent variables. And I will now go to Tools, Data Analysis, Regression again. Now I'm going to change the Y input range to AF. And I'm going to change the X input range to the remaining independent variables. Again, Control-Shift down arrow. Labels are still correct. The output will be in AH1. When I click OK, I get this output. We're now accounting for 81% of the variance, and we have the variables shown here. Now if we look again at the p-values, sanitation is still statistically significant. None of the others are. But we look again for the largest of the p-values, and in this case that is the p-value for total fertility rate. So the next step will be to eliminate total fertility rate. I'll use the same process. I'll copy the data and I will move to the right and paste the data in AR1. And now I will delete total fertility rate. Now the next step will be to repeat the regression analysis. After the elimination of total fertility rate, the next largest probability was health services. So that variable was eliminated in the next analysis, which used this data set. At the conclusion of that analysis, there was only one variable, female literacy, which had a p-value greater than 0.05. So we'll repeat the process one more time and eliminate female literacy. We'll copy the data we'll paste it here in CE1 and we will eliminate female literacy. Now we'll repeat the regression analysis, tools, data analysis, regression. The dependent variable is under 5 mortality. The independent variable set now includes only sanitation, DPT, CPR, and the log of GNP. Control-Shift down arrow, and the output will go in CM1. Click OK, and here are the results. Sanitation has a p-value of less than 0.05, as does DPT, as does CPR, and as does log of GNP. At this point, as we now have only statistically significant coefficients in the model, we would say that our best predictor model using backward elimination will include sanitation, DPT, CPR, and log GNP to predict under 5 mortality.